In this video, we're going to be talking about distributional forecasts and prediction intervals. Now, whenever we are making some sort of a forecast, let's say for GDP growth rate, and we say that GDP growth rate in the next quarter is going to be 1%, that is a point forecast, okay? And it is typically measured as the mean of the distribution of or the possible values of the forecasts that are out there, or the mean of the possible values that might occur. Now, we might want to try to understand what is the uncertainty associated with our point forecasts. And we can do so by looking at forecast distributions, which tell us what is the uncertainty of a forecast based on a certain probability. So if we're saying that GDP growth rate is going to be 1% next quarter, then we might want to understand, well, is it going to lie between 0.5% and 2% with a certain, or 0.5% and 1.5% with a certain probability? And what is that probability? Are we 95% confident that it's going to lie between that interval, or are we 80% confident? And that's what we're looking at. Okay. So most time series will produce normally distributed forecasts. And here, if we look back at the 4 different types of models, or the benchmark models that we were considering, here the distribution of the forecast. So here you have a forecast, which is y hat t plus h, which is the forecast h periods ahead based on the information that's given at time t. We're saying that this is usually normally distributed with mean. The first value here is going to be the mean, which is y bar. Okay, so if you're looking at the mean, this is the average value of y, and so that is going to be the point forecast. And then the next thing that appears here is going to be the variance that is associated with it. So we're saying that if we are looking at the mean model, then the forecast is going to be normally distributed with mean y bar and variance, which is equal to this term right here, okay? And here, your sigma hat represents standard deviation. We can look at other types of models as well, and we can see that at each point, the value of the first term here is basically the point forecast that is associated with those models. Okay, so this is something we've covered before, so I won't go into that. But we also have the variance associated with those forecasts. So notice, like, for instance, if we look at the naive model, this is saying that the variance is h times sigma hat square, which is to say that as h increases, which is as the forecast horizon increases, then the variance associated with our forecasts is also going to go up. Okay, and you can see that here as well. So whenever h is equal to 1 and t is very large, that means the length of our time series is very large, all of these would give the same approximate forecast variance, which is sigma hat square. Okay, but usually we are trying to forecast not just one period ahead, but many periods ahead. So the variance is going to vary with the forecast horizon. So remember that point forecasts have absolutely no value. If I make a statement like GDP growth rate is going to be 1% in the next quarter, that has no value if I don't tell you what the prediction intervals are, or what is the uncertainty associated with that forecast. Well, if I'm just making a point forecast like that, then it can fluctuate a lot. It can be 4%, it can be negative 1%. Typically, we want our prediction intervals to be tight. That means we want it to be close to that 1% value, okay? So a prediction interval, PI for short, gives a region within which we expect the forecast to lie with a specific or specified probability. Okay, and assuming that forecast errors are normally distributed. Now, this might not be the case for many different time series that we'll discuss later, but for the most part, if we make this assumption on our forecast error, then a 95% prediction interval is usually given by the value of the forecast plus minus 1.96 times the standard deviation associated with the forecast. Okay, so this is going to be varying with the forecast horizon itself. So sigma hat h is the standard deviation of the h step ahead forecast distribution. Okay, and if h is equal to 1, this is typically estimated from the residuals itself. So usually 95% prediction intervals are the standard or the gold standard when you're reporting forecasts and talking about prediction intervals, but there are other values as well. Sometimes you might want to look at 90% or 80% prediction intervals. So the book actually, your book actually has this nice table which talks about what are these coverage probabilities. Like in this case, it's 1.96 associated with a 95% prediction interval, but those multipliers are going to be different based on different prediction intervals. So we can take an example and try to look at this. So recall that we had worked with the Facebook underscore stock time series before, and we can try to fit a model, a naive model, on the closing prices of the Facebook stock. So let's call that fit, okay? And then we can forecast using fit. Now, the forecast itself, right, is going to present a forecasting table here, okay? And it is going to give you the model here and the forecast itself and the distribution associated with the forecast. Now, there are different ways of getting to what the prediction intervals are. There is a more involved way here that I will let you read from the book. Okay, this is more involved, but the forecast function itself helps us do this. So if we forecast one period ahead using the model, which we have in this argument here, which is called fit, we can then transmute. You can use this command after the pipe function, and you can say interval equals hilo. So the hilo function here actually lets us, it gives us like this shortcut to get our prediction intervals based on the distribution. So the distribution usually has our point forecast and the standard deviation, and what we need is the 95% prediction intervals. So when you look at what the output is here, this is going to tell us that the one step ahead forecast of Facebook is going to lie between 166.7 and 184.7. This is the value of the stock price. This is the low bar, this is the upper bar. With 95% confidence, we can say that the value is going to lie between these 2 points here. So just to summarize, point forecasts are often useless without a measure of uncertainty, such as prediction intervals. Prediction intervals would require a stochastic type of model with some errors, etc., which we'll talk about later. And anytime we are dealing with multi-step forecasts, that means if you have H, which is your forecast horizon, greater than 1 for any time series, that would require a more sophisticated approach. With the prediction intervals getting wider and wider as the forecast horizon increases. That means the uncertainty associated with a forecast that is 10 periods ahead is going to be more than the uncertainty associated with a forecast that is 5 periods ahead, for instance. And so you can always change the level argument to control the coverage. Okay, so notice that when we were here, we said level equals 95. If you want 80% prediction intervals, then you can change that. So this helps us. And in the next few videos, we are going to talk about the residual diagnostics and accuracy tests for our forecasts.